For decades, the U.S. military has relied on defense contractors to design and maintain its most advanced weapons. While this partnership has produced powerful technologies, from stealth aircraft to precision missiles, it has also created a major challenge: dependence on a single contractor for critical systems. Today, that problem is becoming harder to ignore. One clear example is the massive GBU-57 bunker-busting bomb. Recent efforts by the Pentagon to reverse engineer parts of the weapon using technology from the Army Tactical Missile System signal more than a technical update. They represent a strategic move to break what defense planners call vendor lock. If successful, this approach could reshape how some of America's most important weapons are developed and produced in the future. America's most powerful conventional bunker buster. The GBU-57 Massive Ordnance Penetrator is one of the most specialized weapons in the U.S. arsenal. Weighing about 30,000 pounds, it is designed to destroy deeply buried and heavily fortified underground targets. Modern military facilities, such as nuclear laboratories, missile bunkers, and command centers, are often built far beneath layers of rock and reinforced concrete to survive airstrikes. The MOP was developed specifically to defeat those defenses. Unlike typical bombs that explode on impact, the MOP is built to drill deep into the ground before detonating. Its hardened casing allows it to penetrate concrete and rock, while delayed fuses trigger the explosion only after reaching the target depth. Originally designed with underground nuclear sites in mind, the weapon is also relevant against hardened facilities in countries like North Korea and China. As more military infrastructure moves underground, the Massive Ordnance Penetrator remains one of the few conventional weapons capable of destroying these hidden targets. A weapon built from several critical components. Although the GBU-57 is often described as a single bomb, it is actually a system made of several key components. At its core is the BLU-127 penetrating warhead, a heavy steel body designed to smash through rock and reinforced concrete. It also uses delayed action fuses that trigger the explosion only after deep penetration. One of the most important parts sits at the rear, the KMU-612 tail kit. This section contains the guidance system that uses GPS and inertial navigation to steer the bomb precisely to its target. Without this guidance package, the weapon would simply fall like a massive steel object. With it, the bomb becomes a highly accurate bunker buster, and this critical tail kit is where the Pentagon's current challenge begins. The hidden problem: vendor lock. For nearly 2 decades, the Massive Ordnance Penetrator program has been closely tied to Boeing, the weapon's original manufacturer. Over time, the company developed not only the hardware, but also the software, guidance algorithms, testing equipment, and production methods for the system. Much of this intellectual property remains under Boeing's control rather than the government's. This situation creates what defense officials call vendor lock. In simple terms, if the Air Force needs more GBU-57 bombs or upgrades and maintenance, it must rely on Boeing, because no other manufacturer can easily produce the system. The lack of competition can limit production, keep costs high, and make it difficult to increase manufacturing quickly during a crisis. For years, this risk was mostly theoretical, but recent events have forced the Pentagon to confront it more seriously. A wake-up call for the Pentagon. A major operation involving the GBU-57 revealed the limits of the current system. When B-2 stealth bombers used the weapon against hardened targets, it proved the bomb's immense power, but also exposed a problem: the weapons are scarce and slow to produce. Each GBU-57 is expensive and relies on specialized manufacturing and a tightly controlled supply chain. After the operation, the Air Force needed to replenish its stockpile, but had little choice except to award another sole-source contract to Boeing, since no other company could produce the weapon quickly. For Pentagon planners, the situation highlighted the risks of depending on a single supplier for such a critical capability. The 5-year problem. One obvious solution would be to develop a completely new tail kit for the bomb. One designed under full government control, allowing multiple companies to compete for production. However, defense acquisition studies showed that building an entirely new guidance system from scratch could take around 50 months, or more than 4 years. In the rapidly changing global security environment, that timeline is far from ideal. Military planners worry about emerging threats, expanding underground infrastructure, and the growing importance of hardened facilities in potential conflicts. Waiting half a decade to redesign a key weapon system could leave a dangerous capability gap. So the Pentagon began looking for a shortcut, a clever workaround. The breakthrough came in August 2025 when U.S. engineers reverse-engineered a key component of the MOP using technology from the Army Tactical Missile System. Army Tactical Missile System is a long-range precision missile with advanced guidance and navigation systems, technologies similar to those needed to guide a massive bunker buster like the MOP. By adapting parts of this missile technology, engineers were able to recreate an important element of the bomb's guidance system. This approach reportedly saved about 4 years of development time, allowing the Pentagon to avoid designing a completely new system. While the exact component remains undisclosed, analysts believe it likely involves navigation or flight control systems within the tail kit. An unusual industrial overlap. The Army Tactical Missile System missile is produced by Lockheed Martin, not Boeing. That means technology originally developed under one defense program is now being adapted to reduce dependence on a different contractor. This kind of cross-program integration is relatively rare in traditional defense acquisition. Historically, weapons systems were designed as closed ecosystems controlled by a single prime contractor. Each program had its own proprietary technologies and supply chains, making it difficult to mix components across different platforms. But the Pentagon is increasingly exploring modular design strategies, where technologies developed for one system can be adapted for another. The reverse engineering effort tied to the GBU-57 is one of the clearest examples of this strategy in action. Breaking the monopoly, one component at a time. The Pentagon isn't trying to replace Boeing overnight. Instead, it is gradually reducing dependence by separating control of the weapons components. One success has already come with the MOP warhead casing, which is now under government control, allowing multiple manufacturers to compete to produce it. However, the tail kit, the bomb's guidance system, remains tightly controlled by Boeing. When the government asked to purchase the intellectual property rights, the company declined. As a result, the Pentagon is now pursuing alternatives through reverse engineering and modular technology integration. Why underground targets are becoming more important? The urgency behind these efforts reflects broader trends in global military strategy. Countries concerned about American air power have increasingly invested in deep underground infrastructure. Nuclear facilities, command bunkers, missile silos, and weapons laboratories are often buried under mountains or reinforced with thick concrete layers. Iran, for example, has expanded its underground nuclear infrastructure in recent years. Similar hardened facilities exist in North Korea's missile complexes and China's underground command networks. These structures are intentionally designed to survive conventional airstrikes. Right now, the GBU-57 remains one of the only conventional weapons capable of reaching many of these targets. But it also has limitations. A high-value, low-density weapon. Despite its power, the Massive Ordnance Penetrator is not widely deployable. Only the B-2 Spirit stealth bomber can carry the weapon operationally, and each aircraft can carry just 2 bombs at a time due to the weapon's massive size. The next-generation B-21 Raider stealth bomber is expected to carry the weapon as well, although early estimates suggest it may only carry 1 Massive Ordnance Penetrator per aircraft. This makes the weapon a high-value but low-density asset. In other words, every single bomb matters. Production capacity, supply chain resilience, and maintenance flexibility become critical when dealing with a weapon that exists in relatively small numbers but plays an outsized strategic role. A larger shift in defense procurement. The story of the GBU-57 is also part of a much larger transformation inside the Pentagon. For years, massive programs like the F-35 fighter jet have revealed the risks of contractor dominance over intellectual property. When a single company controls the design, software, and support infrastructure, it can limit competition and slow innovation. Defense officials have increasingly emphasized the need for open architectures, where multiple companies can contribute components and upgrades to a system. This approach encourages competition, speeds innovation, and reduces the risk of bottlenecks in production or maintenance. The reverse engineering of massive ordnance penetrator components using missile technology fits directly into that philosophy. A next-generation penetrator. Even as the Pentagon works to modernize the existing system, development is already underway on a successor weapon known as the next-generation penetrator. While Boeing remains involved in early work on the project, defense officials are expected to apply lessons learned from the MOP program, especially regarding intellectual property and competition. Future weapons may be designed from the start with modular systems and government-owned technical data, ensuring that multiple companies can compete to produce components. If that model succeeds, it could dramatically reshape the defense industrial landscape. A quiet but important transformation. Reverse engineering parts of the GBU-57 may seem like a small technical step, but it reflects a larger shift in how the Pentagon develops weapons. For decades, many defense programs were controlled by a single contractor, producing powerful technology but also creating long-term dependency. Now, the U.S. military is exploring a new approach, encouraging competition, reducing monopolies, and reusing technologies across different systems. As underground military facilities become deeper and more protected, maintaining and improving weapons like the Massive Ordnance Penetrator may become just as important as the weapons themselves. If you enjoyed this deep dive into modern military technology, make sure to like and subscribe for more stories about the weapons, strategies, and innovations shaping the future of warfare.